You've made it. All right, welcome back to another microeconomics video. I apologize for the quality of the audio, but let's go ahead and just get started. So when we're talking about this shutdown, let's go ahead and get rid of all this stuff. We already talked about this in the last video, so if you have any questions about that, you can feel free to go there. So we talked about our cost curves. We talked about how there's a U-shaped average total cost. We talked about how there's an average variable cost that gets closer to average total cost. Now let's think about this. Why does average variable cost get closer to average total cost as the quantity increases? So the number of products, right? The Q. And this is our dollar sign. So the reason for that, right? So this is kind of, we have to learn how to draw these things. We have to learn, the method to them, right? So the average variable cost, it's following the average total cost curve. And at first, it's pretty far away, right? It's, 1, 2, 3, 4. It's 4 boxes away, which you can't really see on the projector, but you can see it in the video. Now, the reason why this is so far away is because at this very early stage here, the average fixed costs are very large. As we increase our quantity, our average fixed cost gets smaller and smaller and smaller. Why does our average fixed cost, so this is a good discussion kind of, why does AFC decrease as quantity increases? Yes?
The cost doesn't actually go up, so you're just averaging out more.
Very good. Yes, very good. The answer is because the fixed cost is not increasing or decreasing, right? It's fixed cost, right? So the fixed cost, let's say that the fixed cost is equal to 100, right? So when quantity is equal to 3, the fixed costs are equal to 100. The average fixed costs are equal to 100 divided by 3, right? Which is, 33.3 or something. When the quantity is equal to 30, the fixed costs are still 100, and so our average fixed cost is now 100 over 30, and so it's going to be 3.3 repeating, right? So it's, 10% less. It's an order of magnitude less as we increase the quantity. And so the reason why I'm talking about this, right, even though the fact is, I bet some of you are like, Dr. MacArthur, we never put the average fixed cost curve on these cost curves, right? We never kind of talk about them besides defining them, right? So why am I bringing this up? Well, I'm bringing this up because if you see that this is 4 right here, this distance is also 4, right? If you draw the graph correctly. And the reason why is because of this little identity, right? So we know that average total cost is equal to average fixed cost plus average variable cost. Well, let's go ahead and isolate average variable cost, right? So we're going to isolate average fixed cost. So we're going to minus average variable cost from both sides. So that means that my average total cost minus my average variable cost is equal to my average fixed cost, right? That's why I'm, doing this, the difference between these two is 2.5. And if I'm doing my calculations correct, I didn't, but this should also be 2.5, right? So whatever the distance is between, and let's just make that clear that I meant the distance between these two. Whatever the distance is between these two, that is the average fixed cost of whatever that is, right? This is 1, 2, 3, 4, 5. So that's the average fixed cost of that 5th unit, is the difference between the average total and the average variable cost. So that's why the average variable cost essentially gets closer and closer and closer to the average total cost as we go from left to right on the graph. Does that kind of check out with everybody now? Cool. Seeing some head nods. It's also on YouTube if you need to rewatch it, right? Okay, so how far can we go? Excellent. So we're really not going to be using this average fixed cost besides this. And then our last cost curve that we want to talk about is our marginal cost curve, right? So our marginal cost curve looks something like this, a Nike swoosh sign. And the marginal cost curve, if written correctly, if drawn correctly, should go through the bottommost part of the average variable cost curve. And the fact that the average fixed cost curve crosses there is purely accidental. So don't take anything from that. But the marginal cost curve always goes through the bottommost point of the average variable cost curve and the bottommost point of the average total cost curve, right? And if it doesn't look quite right, you can always law of mass dots, or big dots, right, to make it kind of fudge it a little bit. And this marginal cost curve, that's where we're going to be doing our incremental analysis, right? We know that our golden rule in economics for profit maximization is we're going to choose Q star where our marginal revenue is equal to our marginal cost, right? That's our golden rule of incremental or marginal analysis. And so we've got the marginal cost bit here. But in order to really complete this graph, what do we need, right? If we're talking, again, we're in chapter 8, what does that mean? That means we're in perfectly competitive market land, right? So perfectly competitive market land, well, I need to draw my actual market curve then, right? Because what is happening? How is price being determined when you're in a perfectly competitive market? It's being determined in the actual market, right? So this, if this is my alfalfa farm, right? If this is Chris's alfalfa farm, this is the alfalfa. Of course, I can't like spell that now. This is the alfalfa market, right? And so this is going to tell me what my equilibrium price is. You know, let's say the equilibrium price is 4.5 or something like that, right? We're going to take that equilibrium price, we're going to reflect it over onto this individual graph. And we'll use a yellow highlighter here. We're going to draw hopefully straighter than that, a demand equal to my marginal revenue curve. And from there, I'm going to find where they meet, and that's going to determine my Q star. So that's just kind of a review. Now let's talk about the fact that, so we know that just because, so this profit maximization rule, right? Just doing this does not guarantee a positive economic profit. So this is, and that's part of the reason why this rule is often talked about as a profit maximizing, but the flip side of that is, or loss minimizing. So sometimes profit maximization is getting the least amount of loss, right? If you think about profit as a positive or a negative number, when it's negative, that's a loss. So you want to, lose $50 instead of losing $7,000, right? So, in that case, the lower number is better, right? It's like golf. So let's talk about a couple of situations like this. So we already talked about, and this might have been in the video, so I'll just kind of review it real quick. But we already talked about how, the dynamics that play out between the market and the individual firms. Right? So the dynamics that play out because of the characteristics that we have in perfectly competitive markets, right? So the characteristics that we have, there's many buyers, there's many sellers. There's an identical product. There are no barriers to entry, and there's free information. Everybody knows what's going on, okay? So we have to keep that in mind, because that's a lot of the dynamics are because of those assumptions of the market type. All right. So again, we've got some sort of, this is our market. This is our firm. We've got some sort of supply and demand situation over here. creating some equilibrium price. We've got a U-shaped average total cost curve. We've got a average variable cost curve that's getting closer and closer to my average total cost curve as time goes on. And then we've got a marginal cost curve that's looking something like this, right? I'm trying to get it through the bottommost part of both my average total cost and my average variable cost curve. So in this particular situation, right, the way that I drew it, and again, we're kind of going to do a little bit of fudging here just because I want the price to be a little bit higher. So I know that that's kind of sloping a little up, but that's fine. And so we're going to say, okay, given that P star there, this is my marginal revenue curve. And so again, my optimal decision, right, the thing that I'm going to do is I'm going to do Q star where the marginal revenue is equal to the marginal cost. So I'm going to find my marginal cost, find my marginal revenue, and then I'm going to drop an anchor down and get my Q star. And at this particular point, right, we talked about profit margins and average profit and stuff like that, right? And we had a rule that we talked about last class and in the video, that if the price is above the average total cost at the profit maximizing quantity, then they are making a positive profit. And the way for us to actually show that is to look at this rectangle here that is above the average total cost curve, but below the demand or the marginal revenue curve. This is telling us how much actual profit is being made. It's called the profit rectangle. Now again, what's the dynamics? What's going on here? Well, there's free information. There's free entry and exit. If you're making something that is a competitor to this, right? Let's say you're also in the perfectly competitive world, and you see that some other firm is making this abnormally positive high economic profit. What are you going to do, right? You're incentivized to enter the market. So because of the fact that there's high profits being realized, there's free information, and there's no barriers to entry, that's going to cause our supply curve to shift outward. And at this new supply curve, what's that going to do to price? It's going to depress it, right? There's going to be some downward pressure on price, and we're going to have some upwards pressure on our quantity supplied at this new supply, because there's just an increase in the number of sellers. What is this going to do to this individual firm? Well, at this new price here, and again, let me fudge it a little bit just for the sake of example. So at this new P double star here, now my marginal revenue is down here. And so again, I know there's a lot of lines on this curve, or there's a lot of lines on this graph, right, with curves and straight lines or whatever, but at the end of the day, we have to focus on what's our profit maximizing rule. We're going to be doing this for the next 4 chapters, right? Q star is where marginal revenue equals marginal cost. So we find our marginal cost, that hasn't changed, and we find where that intersects our new marginal revenue. X marks the spot, then we drop an anchor, and we label it our new equilibrium quantity. Now, what is going on here with the firm, right? So before we had the situation that they were making a profit, right? Because the price was above the average total cost curve in that particular situation, right? But what is going on here now? It would help if I didn't erase all of the average total cost curve, right? So at this particular quantity, we have to actually go up to get our average total cost, right? And we can see just visually that our average total cost here, and we'll call it average total cost at Q double star, right? Our average total cost here is going to be higher than our P double star, than our equilibrium. And so this right here, from here to here, all the way over here, this is our loss rectangle. So again, this profit maximization rule does not guarantee we're actually making a profit, right? We're using that rule and we're making a loss. But what is happening here, right? This is why I kind of went on the tangent earlier about how profit maximizing, the flip side of that is loss minimizing. So this is going to cause the least amount of loss for the company given the new market conditions, given the new price, demand curve, and marginal revenue curve, right? And remember, in perfect competition, they are all the same thing. That is probably one of the more confusing things for a lot of students, the fact that they are all the same thing in perfectly competitive firms. Now, the whole point of this section is the shutdown point. So part of what we're asking ourselves is, why would we keep operating if this were the case? Let's say that I calculated this loss and I figured out that this loss rectangle was equal to $200. What if I also told you that the fixed costs for the whole business is equal to $320? So let's kind of think about this and toss this around in our brain for a second. Would you rather stay in business and lose $200, or would you rather shut down and lose $320? So part of the issue is we can't just shut everything down and walk away. We signed a lease. We have commitments. We might own the building or whatever the case may be, right? So when our loss is less than our fixed costs, we're going to want to go ahead and we're going to want to stay in business for the short run, right? So when the loss is less than the fixed cost, you'll want to stay in business in the short run. Because essentially losing $200 is better than losing $320. So it's a game of golf, right? You want the lower score. You want the lower amount of money that somebody's taking away from you every month, right? Now, what happens when the price drops even lower? So right now, essentially, I'll clue you in that the shutdown point, and we'll do an example real quick, the shutdown point is right here. As long as the price is above where the marginal cost, let's go ahead and label this somehow. So the shutdown point. Whenever the price falls to a level below that average variable cost curve, that means that essentially you are no longer losing less money than if you just closed down and swallowed the fact that you owe $320 every month on rent. If the price drops that low, there's no amount of profit maximization, loss minimization that can mitigate the fixed costs. And in fact, if you continue to operate, you're going to lose $480 instead of $320. So as long as you can recoup some of your fixed costs, you want to stay in business, at least in the short run. Because what's going to happen is other people, seeing that they are now at a loss and there's free entry and exit, they're going to leave the industry, right? So the supply is going to shift back inwards, the price is going to go back up, and it's going to find some sort of equilibrium. But if the price, and so let's do one more example. I know it's a lot to draw. I'll just try to be real quick here. Boop, 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 boop. So if we had a situation where the supply started out here, shifted out tremendously, so that our new, and again, I didn't even do that correctly. Nope. So that our new equilibrium price is all the way down here. Now we're going to have a marginal revenue curve that is completely below my average variable cost curve, right? So if this is my situation and I find that my marginal cost and my marginal revenue, right, that this Q star is below my average variable cost, then the correct Q star is actually, so let's say that this Q star was equal to, 250 or something, right? The correct answer on the test or in the homework is actually going to be no. The profit maximizing or loss minimizing quantity for this particular case, since the way that these curves are drawn, the actual Q star, the answer is actually 0. So if the Q star, if the MR equals MC Q star is less than the average variable cost, then the Q star is actually 0, right? Then the equilibrium quantity that's going to minimize your loss is actually going to be 0 rather than producing the 250, getting some revenue, but then, again, losing more than the fixed cost, more than the $320. Does that make sense, everyone? So if it's below the average variable cost, you want to shut down. If it's above the average variable cost, but below the average total cost, right? So if it's anywhere in this particular region, right? This is the region where you're going to want to stay in business just for the short run and hope that other people exit the industry and the price increases. If you're in this part, well, times are good. You're earning an economic profit. So this is our shutdown zone, all of this down here. This is our stay in business in the short run zone. And this is our times are good, I'm running a positive economic profit zone. Does that make sense to everybody now? And the book has a really good diagram about it and some good explanations, so I implore you to take a look at that part of the book. Excellent. And I can also find more resources and provide more resources and more examples about this too, if anybody needs.